Welcome 7th grade. Glad to have you here. Today we get to start talking about chordates and vertebrates. Alright, we've done all the invertebrates. I know, believe it or not, we've already gone pretty far. And now we move here. We're getting very close to talking about amphibians, and most of you know what comes along with that. Alright, chordate characteristics. You get the generals today, then we get into specific groups tomorrow. Notochord. It's the structure that becomes the backbone. Post-anal tail. Nerve cord. That is the structure that becomes the brain and the spinal cord. And then the pharyngeal pouches. That's the structure between the mouth and the digestive tubes. We see all these things kind of pictured right here in a young fetus or item like that. But remember, they're going to put a high emphasis on a lot of evolutionary stuff. We as Christians can believe otherwise. All right? And they think they become the gills in fish. So a lot of structures, a lot of embryos have this same starting form, and then they go and become different things. And they become the tubes from the ear to the throat in mammals. You've heard of ENTs, ear, nose, throat doctors. That's because these tubes are from the pharyngeal pouches. They all have a similar structure, so they work on all those. Vertebrate characteristics. Endoskeleton, skeleton on the inside of the body. It's made by bone or cartilage. Examples of these bone types might be the skull, the vertebrae, radius, ulna, femur, and you've probably named many of the other ones for health. You can see them listed here, and you're going to see that there's a lot of carryover between many of our vertebrates. Now, cartilage. Cartilage is flexible tissue. Nose and ears are examples of cartilage on humans, and you can see that with this part of your nose here. Also, when you see skulls, you notice the nose part is missing. Ears, that flexible part here, that is cartilage. And sharks, their entire structure is cartilage. The only thing calcified on them is the teeth that they have. That's why that's the only part of them we usually find. All right. Vertebrate groups. We have ectotherms and we have endotherms. We're going to give you a few characteristics about each, and then I suggest you look at page 396 for the table that's there. Now, ectotherms, the body temperature changes with the climate. All right? They're very related to the outside temperature. Examples are fish, amphibians, and reptiles. These are often referred to as cold-blooded animals, aka is also known as. All right? Endotherms. Body temperature does not change with the climate. Well, hopefully. If it does, there's real troubles. Examples, birds and mammals. They're known as warm-blooded. All right? With us endotherms, if we were to put you outside on these cold days and your body temperature would drop by too much, your body organs and other things would start to shut down and you would eventually die. All right? So, endotherms try to maintain a homeostasis or a temperature that is the same all the time. Where ectotherms, their bodies can range with the temperature of the climate to a certain extent. Chordate characteristics. Notochord. This slide looks familiar. Structure that becomes the backbone. Post-anal tail. Nerve cord. Structure that becomes the spine and brain, or the spinal cord and brain. Pharyngeal pouches. And we have the three uses for them, or the three things they become. So, guys, I hope you saw the slide that was on there twice and realized what's important. Thank you so much. Goodbye.